Okay. Okay. Hi, Dr. Reck. I wanted to just start with having you introduce yourself and tell us how you're connected to Boston Harbor Elementary School.
Right, so, hello, I'm Dr. Penny Reck. A lot of you know me as Mrs. Reck, as Tristan, Tatiana's, and Simone, if you remember Simone at Boston Harbor, their mom. Um, we have lived in Olympia since 2008, moved to Boston Harbor in 2017, and basically just proud members of the PTA and just proud to be part of the Boston Harbor community. So,
Awesome. And Tatiana is in which grade?
Tatiana's in first grade with
Okay.
Miss Myers,
And
and
Tristan is
Tristan is in fifth grade, which I still can't believe he's that old. In his last
okay.
year at Boston Harbor with Mrs. Vay.
Okay. Well, thank you. And can you tell us a little bit about your work?
So, I am a doctor, and specifically, I'm a retina specialist. What does that mean? A lot of times I'll just say I'm an eye doctor, but a lot of people think that eye doctors mean doctors who just check you for glasses and can make you all better with glasses or contact lenses. That is not what I do. I am a retina specialist, which means I specialize in the back part of the eye. Specifically, I'm a retina surgeon, so I have special training to do surgery on the retina. And I'm happy to get more into that. I have some props here to
Oh,
explain.
yeah. We love
um,
pictures.
so we actually I have a little eye model here. This is the eye,
Oh,
and
very cool.
it's a little foam model. And basically, we see by how light travels through the eye. So light travels through, it's first focused by the surface here, that's the cornea, goes through that pupil, that's that black hole right here. It's not totally aligned perfectly, but I'm gonna open it up.
Whoa.
Then basically, if you think about the light rays here, we're still going through here. The retina is this thin tissue that lines the back of the eye. It's basically like your movie screen. And it's a neural tissue that basically is similar to like how brain tissue is like very specifically organized. But this is basically light rays travel through, it's projected onto the retina. The retina has photoreceptor special cells that make the signal happen and travel to the optic nerve. The optic nerve is a cable that connects to your brain, and that's how you see. So I operate and I take care of diseases in the back here. Um, Generally, if you have to see me, you have something serious going on. So hopefully you never have to see someone like myself. But if so, just know that there are highly trained professionals here to take care of you. Um,
That's very, I was shocked when you opened that up. So is the cable that you talked about is what the red line that we can see going out the other side there? That's how it
so
connects
here,
to the
so
brain.
here, basically, yeah, this part is this is the optic nerve. This is actually what my husband takes care of a lot with glaucoma.
Oh,
But this is the cable that connects the eyeball to the brain. But within it, you see like not within it, but around it. Around it are these retinal vessels that supply, come from the arteries in your neck,
right.
travel through, and they branch off, and they supply the vasculature, the blood flow to the retina.
Okay.
So the eye is pretty awesome, I have to say. It is a pretty awesome organ. You can actually just look in, like you don't need an x-ray. I can look in and I can say, hey, looks like you got diabetes or hypertension issues, things like that. It's one of the very special body parts that you can do to really assess someone's health on the inside in many ways.
Mhm.
But we do use a lot of technology, which is one of the best things about my job, which I can get into later.
Yeah, okay. Well, we've been talking about like engineering design process and when there are problems that come up, trying to figure out solutions, trying things, maybe going back to the table, reworking those solutions and trying something else. Does that happen in your work?
So I would say it happens in a way. Probably the easiest way to compare it would be that it happens in developing treatments for retinal problems. So basically, one of the best stories about experimentation and testing and design and things like that is the treatment for a blinding disease called macular degeneration. Now, this is a children's elementary school level talk. So children don't deal with macular degeneration. That is something that is a disease of aging. Um, but a long time ago, it was a disease of aging that was really blinding. It still has the potential to blind, but we actually have amazing treatments nowadays. In 2005, there was a medication that came out for colon cancer, and patients who are getting colon cancer treatment, their chemotherapy, who happen to have severe advanced disease of macular degeneration, advanced macular degeneration, they actually started seeing better. And people looked at this medication and they said, you know what, this is the target for what we need to hit inside the eye for patients with macular degeneration. And there was nothing available on the market at that point to treat patients successfully like that. So one of the major universities in the US said, we're going to do a clinical trial. We're going to use it off label and we're going to try it out. And it ended up being one of the most groundbreaking things that happened in the world of ophthalmology, because patients who would go from, a prognosis of you're going to go blind in 5 years, you're not going to be able to drive, you're going to just see like black spots and where people's faces are and things like that, they were recovering vision and their vision was being maintained, and the vision was being saved. After that, um, many medications started coming out, um, being better, like lasting longer. The first one was used great, but some people, they didn't have as miraculous type of responses. They still were helped, but not in terms of to the extent of, still being able to drive and things like that. And so the pharmaceutical companies started looking at it more and said, okay, what else do we need to attack? And so they started addressing other factors that are at play that cause problems with the disease. And so we actually now have like a handful of drugs to choose from, which is pretty cool.
That's very cool. Okay. And I will say it again, that it's not something that impacts kids. It's something that's
No, it's not something that impacts kids. Not trying to scare anyone.
Yes. No, but
but
that's amazing that it's
it's pretty
been so.
amazing. That disease itself is really common. So
Yeah.
chances are, someone with that disease, even if they don't talk about it.
Mhm.
It's the most common reason why adults over the age of 65 will lose vision in the US. But the good thing is we actually have really good treatment for it now.
That's wonderful. Okay. So my next question is, how did you become interested in this work?
So I became interested in ophthalmology in general during my research time as a medical student. And as a medical student, I was interested in taking care of, kids and adults. And I was just luckily paired with an amazing professor who did research work in visual sciences and ophthalmology. And he um, worked on the retina, looking at animal models, and particularly the goldfish. The goldfish can regenerate its retina. It's
Oh,
pretty amazing.
wow.
It's pretty
Wow.
amazing. And
Yes.
so his line of work was really looking at a lot of the embryonic factors, meaning like before you're born, right? And things that are common across animal species.
Mhm.
That, what makes it that this animal can do something that's potentially like, regenerating vision. Um, and so he was also just a really good mentor, encouraging, had a great personality, and easy to work with, and gave a lot of good advice. So basically, out of that work, I was able to present as a medical student at a conference that generally only really like serious graduate students, levels like
Mhm.
would present at further along in their career. And this convention was like an international convention where they were just presenting research from everywhere. And it's all about saving vision and making people better and see better and be able to function better. And one of the coolest things is like visual sciences uses like cutting edge technology, like lasers. And um, it really got me excited about being part of a field of medicine that you were gonna use technology that
Mhm.
was like coming out Like they would develop it and you would do something just really life-changing with it. So
Wow. So you were inspired and helped along by
yeah,
other people.
yeah.
And then it sounds like you enjoyed that collaborative, like learning from everyone at the conference and that energy about helping people and
Yes,
being a part of
yes,
something
exactly.
cutting edge. Very cool. Okay. And that maybe leads nicely to what's the best part of your job for you?
So, I mean, the best part of my job is that I get to help people, but also I get to meet people. I get to meet a lot of different people, um, different types of people, of ages, different backgrounds. Um, and I also kind of get to peek into what it's like to get older and hear about what families are like, because you chat with people, as they
Mhm.
come in, and you catch up a little bit and see what is happening in their life, and you get an idea, a little window of just what people's lives are and what your life can be as you get older. I think that's really the best part of my job. And of course, like having a positive effect on their life, hopefully, with the treatments, and being their doctor. But that's probably the most fulfilling part
Okay.
of my work.
Very cool. Okay. And then were there certain things that you needed to focus on when you were in school and study to get to where you are in your position now?
So definitely, I would say the math and the science are very important. Those things were things that I just really enjoyed anyway. So I never felt like it was a lot of extra work.
Right.
But I probably did put a lot of work into it. But things like the ELA stuff, like writing and reading, those are also very important. So I would just say, um, whatever you're learning in school, it's just important to work hard at it. Understand that whatever you do, even though you think you're just going to do something that's more like math and science, things like the reading and the writing are definitely very important, especially when it comes to if you're really deep into the science. You have to write papers to
Yeah.
share your knowledge,
Yeah.
and you have to be able to also read a lot of papers to put together data that comes in that also helps support the research you're doing, or maybe even inspire you for another idea for research and things like that.
Right.
So really, I would say, yeah, math and science, very important, but reading and writing, all that stuff should not be discounted as an important part of the process too.
Okay.
Um,
All the things.
everything.
That's good. I like that. That's what I do. So sound of that. Okay. And do you have any other things that you'd like to share with the kids? Like I know you talked a little bit about the cool technology you get to use, and I know you have a couple pictures.
Okay, well, I have a lot of fun things I think that are cool to show you.
We'd love to
Okay,
see it.
so basically, whenever someone comes in for an initial assessment, we like to document what the retina looks like at that point in time. We also like to scan it, and we obviously like to look at it. So I have some pictures to share with you, and also like maybe some equipment to show you that I get to work with. I unfortunately don't have a laser with me I can show you because I'm
But
stuck in the clinic, but it's
so cool
awesome.
you get
Let me
to
tell you.
use a laser though.
Yes, it's awesome. Okay, so basically, first I have this is an example of fundus photography, meaning it takes a picture of the back of the retina. I don't see very many normal fundi, like that's plural for fundus.
Yeah.
So this is just a picture I took off of the internet. But this is what a normal central part of the retina looks like.
Okay.
It's beautiful.
It is.
So
It reminds me a little bit of like a planet or
it looks like Mars, kind of,
yeah,
doesn't it?
it's beautiful.
If you ever went to Mars. Okay. And so that's just basically one of the basic fundus pictures. I'll show you some not normal fundus pictures now. So basically, let me see here. This person has bad diabetes. So I don't know if we can really get a good picture.
Yeah,
You can see like the little red blotches on there maybe. That's one eye that has some problems. His other eye had many problems. You can't even see the optic nerve and the retinal vessels because there's all this scar tissue and bleeding from the diabetes. So this person, like that eye blind, like can only count fingers, see hand motion. And basically through surgery, we got to cut away the scar tissue. And I do that by going into the eye and looking through his eye in a microscope in the operating room. And basically what we did is cut away the scar tissue, and then we laser these areas because that's part of the treatment for really bad diabetic eye disease. It helps tack the retina down, but it also helps stop the drive for the problems due to diabetes. And basically he recovered a lot of vision, able to go back to work. It's like close to 20/20, not quite, but that's not a healthy retina. Yeah. So yeah, so we do that.
Wow, that's amazing.
It means something to the person that we can help, you know, and it's really great. The technology is there to be able to take care of that. Let's see, what else do we have here? I have, oh yeah, so also what we do is we look at the blood flow in eyes too, to look at the health. So this is basically that patient's angiogram of the blood flow prior to surgery. So we can see sort of how extensive the disease. I don't have any normal angiograms. So this is, but basically, if you can see it here, we inject dye through the veins in the arms and it comes up to the eye, and we just take pictures, a video, and then it goes into pictures of the blood flow. So this is the dye just circulating. It's telling us how much blood flow is getting to the eye and the retina, and just how much actually is not happening. And I mean, I can tell, like, that's just, there's not a lot of blood flow there. So that is that case, which is really fun. This is a case about the lasers. So basically this one, I don't know if you can really tell, but this is a fundus photo. And on top here, there's a retinal tear.
Oh, okay.
The retina tore due to some normal factors of getting older. Sometimes people's retinas just tear. And with the laser, I surround it with laser to tack it down so it can't progress to a retinal detachment.
Okay.
The laser is fun, I have to say. It's like, if you like video games, you like lasers, like you like to do retinal lasers.
Yeah.
Or any type of eye lasers, I guess to say, because it takes having to aim it, some hand-eye coordination. There's actually a lot of simulation training nowadays that's very much like a video game.
So you control it with, you use both hands? And
so basically there's two ways to deliver a laser. There's a laser that's hooked up to a microscope. So if you've ever been to the eye doctor, and they look at you, they put your head here and they come close, that's like a microscope. We call it slit lamp. There's a laser that some lasers are made to hook up to that microscope like that. Then you put a special lens on the eye and then you can aim it. Or we actually have what we call indirect ophthalmoscopes, where we look in the eye with these special headsets, which is what I have one here.
Okay.
And in my clinic, we have a special one that has a fiber optic hooked up to a laser, so that the laser beam comes out of here through my spotlight, and I have to aim it into the eye with my lens while keeping the patient's eye open.
Oh my gosh. Okay.
But we get it done, and everything takes practice and training, right? But basically that's how we deliver lasers, and that's how we save vision.
That is so
lasers.
Wow, that is so cool. Oh, well, okay. I think you're inspiring a whole bunch of future people who will be excited to work with lasers here.
Yes.
Thank you. Is there anything you want to share here at the end?
So one of the coolest things is another type of laser where we scan. Actually, it's like through like ultrasound technology. But this is the most common test that we do in the retina clinic. It's called the optical coherence tomography. it does a retina scan. So basically, I think I took a video. So this is an example of us obtaining it. This is,
Oh,
I have
okay.
people volunteer to do it.
Right.
Um, but basically, so
Yep.
they're at the scan, getting it
Mhm. Yeah.
taken and just getting lined up to get it done in one eye. And I was hoping that you could see the laser beam like kind of scan through, but it doesn't. Like you can't visualize it. But we'll go to the screen in a second, and you'll see what it's doing. But it's essentially taking a scan of the retina and looking at the retinal layers and getting a thickness of it. So here we go. You'll see on the screen. This is what it's doing the whole time. So it's scanning up and down
Okay.
across the central part of the retina, which is the macula, which is our most important part that we use to see. And then
Wow.
it captures it. So like in the movies, right? When you were like going to some high tech facility like Mission Impossible or something like that, and they put your face up there, and that's
Right.
the retina scan. This is what they're doing. This is what they're doing to identify like the location of the vessels and things like that.
Mhm.
Um, but this is basically this is what it looks like. And is it? We go through it like we're moving it up and down, looking at all the different layers.
Wow. And
You
so,
go look at it.
and everyone's is unique. Is that why they do
The
the?
retinal pattern, the vascular pattern, is what's unique.
Okay.
These at this current resolution, a lot of them will look kind of the same. Like
Mhm.
that's a normal looking one,
Mhm.
but I'll show you an abnormal looking one.
Okay. Okay.
So this is one with the macular degeneration where the fluid has built up and
Mhm.
leaked underneath. See how you have that black spot there?
Mhm.
And so this is basically looking at where it's located and the extent of it before we perform any treatment.
Okay.
And with treatment, that darkness, that'll go away. It'll start looking like the other one I just showed you. So
Yeah.
anyway, super cool,
Very cool.
very fun.
Yes.
And
Wow. Well, thank you so much for taking the time to inspire us and to teach us a little bit about what you do.
oh yeah, you're welcome. I hope that everyone feels that whatever they want to be when they grow up, right? That you can do it. You can do it. Like the retina surgery world is actually um, it's becoming less male dominated,
Mhm.
but basically um, any like I hope that when you go out there and you want to do whatever you want to do, you don't pay attention to any labels that might still be out there. If you want to do it, you work hard, you go for it, and you're going to be able to do it.
Awesome. And find those mentors, find the people who inspire you and connect with
Yes.
other people like you did. Okay.
Yes.
Wonderful. Okay. Well, thank you. I'm going to turn this recording off here.